Well, hello everybody. Welcome to the Don Bruner Back to Business Show. We're broadcasting today from Global Voice Studios, and today's date, of course, is March the 20th. Today's presentation is kind of interesting, a little bit confusing, and we're going to talk about what's all this about the clouds. And that's about the latest in harnessing the power of computing. And we hope that you'll find that very interesting. We've got a few other things, time available, that we'll be discussing, and we'll get into that as we go. In the meantime, let's get started. Well, if we look at the development of the computer, we can go back, probably into the 70s and the 80s maybe is when it really started to come about. If you look in the beginning, what they had was mainframe applications with dumb terminals sitting on a desk. And when we say a dumb terminal, what we're really saying is that it really had no computing capacity in itself. Everything had to be done on the server. And these servers were usually located within the same building where you were located at. And everything was connected by wires. Most of these things were really relegated to accounting duties, and those are about the only people who had them. As we moved on, you got desktop applications with the advent of the PC. And that's when things started to really open up to the ordinary man working for applications. You probably remember the early spreadsheets and the word processing things. Then as that happened, you got distributed servers. So you had these servers located in multiple buildings, and they could communicate together. So again, those were done usually by batch processes and were consolidated either going down into a desktop or done on a mainframe. Once we started going beyond that, then you started getting into internet, the advent of the internet. And what you had then was consolidated high-density servers located in servers to where the hardware was kind of outsourced out because those functions got to be big and complicated, and the skills to maintain them was quite extensive, and that talent just didn't reside in the normal small business. You got into the internet applications then from just website hosting, and that's when software began to move out of the box on the residing on your computer and residing on the internet. And from a hardware standpoint, those big servers weren't affordable by most of the businesses, so now we moved into the area of virtual machines. When we're talking about a virtual machines, that big server that's located somewhere else, and gosh knows where, smaller companies can take what they need, and it's really computing on demand is what it comes down to. And that's where we are today with the advent of the cloud. Virtually anything can be located on that computer, whether it be a desktop application, a spreadsheet, a customer service thing, calendars, word processors, you name it. It's all located on the servers. Who knows where in the world it's located. You have what you need and only what you need, and it's on demand. So if your computing power needs suddenly for an instant go up, you have it available because all of these networks are all linked together all over the world. It's an amazing world that we're into, and we're just seeing the beginning of it. As we move on to slide 3, we're going to begin to actually go into the concepts of the cloud itself. We're going to call it demystifying the cloud. And that's how do the data centers keep all the information bound to Earth. Okay, now, when we're saying the cloud, it's kind of a meaningless term. And people use it all the time, and they really discuss it in various ways, and they discuss it in terms of the applications, the websites, the servers in terms of the countless sites and the things that are internet related. But what does all of this stuff really, what does it really mean, and what can you really do with it? And that's what we're going to try and go into and get some concept of a meaning to it rather than just that mystifying term out in the clouds. Moving on to slide 4, we're going to really try and come up with a simple explanation of what the cloud is. What it really is it's a massive physical collection of interconnected information technology servers that are really accessible by the users throughout the network. The advances in technology have allowed the network to essentially be outsourced. This has had a large impact on business the world over. And outsourced, they can be anywhere in the whole world. If you really look at it, 80% of the CIOs have some form of infrastructure delivered through a cloud network, and 84% of the CIOs who have moved to the cloud have cut their application costs. Now when we're saying cut their application costs, that's on a per user basis. And 21% is the amount of the annual savings for users who move applications to the cloud. In an enterprise operation, that's a big number. Now, because of the growth and benefits of the cloud computing, 60% of CIOs have stated that their number one priority is cloud computing, and of the budgets that are estimated to be spent on cloud computing in 2013, that was 2 years ago, 33% of their budgets are being spent on cloud computing. That's a pretty big number too. Moving on to slide 5, we have to ask ourselves, well, where does this cloud thing really reside? Well, a lot of people think that it's some kind of a magical network of servers just floating up in space somewhere. But that really isn't true. The cloud is actually in data centers in many, many physical locations all the way across the earth. Thousands of data centers exist around the world. Most of them are in the United States and Europe, and a lot of growth and development occurring in Asia and Australia now. If we look at the usage, it's really been because of the internet, and that's been just a massive growth. From about year 2000 to 2012, you had over a 550% increase in internet usage. That's a bunch. And that's had the effect of standardizing applications, standardizing usage, increasing communication to where thoughts can go across the world at the speed of light, just like money's flying across the world at the speed of light now. It's just an amazing tool. If we look at slide 6, we have to ask ourselves, well, where do they construct all of these different data centers? Well, the first thing you have to look at is they put it where they get the most financial advantage and physical security advantage. They put it in a physical geography that's large and flat surface areas, and a lot of them are probably built underground. They're putting them where there's little climatic risk of natural disasters, earthquakes, cyclones, hurricanes, that sort of thing. And energy is a very big consideration for these things, the cost of electricity. These are massive servers and they require massive amounts of energy. So they put them where natural energy savings are available, whether that be generated by hydraulic water power or geothermal power or wind energy or even solar. But the biggest consideration of all is safety away from crime and targets for terrorism, etc. So I doubt if you've got a lot of them being built in Syria right now. Okay, the next thing is they have to have the availability of high-capacity internet. And obviously, again, we've said affordable energy services. And a big consideration now is the lack of intense laws and policy and regulations. That's getting to be a bigger concern all the time now. Okay, going to slide 7, let's get an idea of how many of these servers there are. Right now, there's probably 50 million physical servers throughout the world. Now, if you take and let's put that into an even larger perspective. Microsoft runs a data center that's the size of 10 football fields. That's a pretty good sized building. And Google They run 500,000 servers in 13 different centers worldwide, and they consume 260 million watts, or the equivalent of 1/100th of the global energy used to power 200,000 homes. If you look at the inner workings of the cloud centers, these data centers are up and running 24 hours a day, 7 days a week. And companies go to great lengths to see that these are functioning smoothly. They are interconnected with fiber optic networks, and data centers connect these things together. And the speed that they run at speeds 200,000 times faster than what a typical home internet connection receives. The wires are all typically color-coded, and you have massive numbers of wires, and everything is done to eliminate as much confusion and increase the worker efficiency. And that's one of the big advantages of cut those costs to 33%. You look at it, and if you've ever been in one, you've got just solid wires and solid machines in there. And when we say that they use electricity, it's not only the servers that are using the electricity. These things build up a tremendous amount of heat, so the air conditioning bills are humongous in there. It's a big cost, and that's all been spread out, and it's available to you basically on demand. That's where all of the savings are really coming from. If we go to slide 8, we're going to try and take a little closer look at what some of these centers are like. Now, if you've ever been in one of these big data centers, it's just rack after rack after rack of computer parts. Try and imagine yourself in a library and replace the stacks of books with stacks of machines, stacks of computers, wires running everywhere down to them, and different boxes. And if you look at when we're talking about computers, we're not talking about kind of like a desktop unit where your hard drives are internal there. No, we're talking about the servers or boxes that have just the computer, the processors, and that sort of thing. Lots and lots of switches, and then lots and lots and lots of hard drives running around. Massive numbers of hard drives. And remember, within these centers, the number one priority is the safety of data. And so they've actually put in a lot more than they need. They have to have a redundancy to where all of that data is backed up. Every bit of it has to be backed up in case there's some kind of an outage. When you stop and think about it, the mechanical failure is really pretty small, and what a hard drive goes through, how fast it spins, and how many times it has to go out and search for bits of information, it's an amazing process. And, quite frankly, there's computer failures all the time. There's thousands and thousands of fans located within these different server boxes. There's fans that sit on top of processors. Fans that keep the boxes cool, and power sources that are in all of these different boxes. So all of these components occasionally fail. So the people that are here are mostly technicians that do a lot of repair work, and everything is done modular. You just take a part out and put a part in. It's amazing. But go back to the days of the early things to where each building that you had its own server. That meant that every building had to have its own technician because those parts still failed. But when they failed, that computer was down. With the redundancy built into these centers throughout the world, and that's a reduction in the total number of technicians that had to be dedicated to repairing them. And again, that's where a lot of the big money savings has come into these corporations. Okay, let's come back now to the use of energy that goes into these things. Remember, we talked about the fans. You have water circulation fans, cooling, heat exchangers. You got all kinds of things that are taking just huge amounts of electricity. Now, if you look at the graph on that thing, you can see the amount of electricity usage that's gone up over the time just because of the use of the internet.
but that's really meant that your information is available to you 24 hours a day, 7 days a week, round the clock, without fail. And quite frankly, the uptime on these things is amazing, and it's astounding. So it's just a wonderful thing to use.
Now, in slide 9, we're going to take a look a little bit closer at the infrastructure of the building. You know, we talked about a library trying to imagine what's in it, but now let's remember that with all of these things, they run hot, and so fire has got to be a concern, and it's all electric and electrical circuits. So they have to have enough space between all of these servers, and the buildings are oftentimes very compartmentalized. You can think of conduits running through all of the air conditioning ducts. They're all sprinklered, but when we're talking about sprinklered, we're not really talking about water sprinklered, because this is all electrical and electronic components. So most of the sprinkling systems are actually CO2 gas. So there are also considerations of the people if you have a fire. You know, if you're putting a fire out with CO2, you're taking all of the air out, so that means people can't breathe. So again, you have to consider the safety of the people and where they're going to be. Also, again, the biggest consideration of all is the redundancy and the protection of the information. If electricity goes down and power outage occurs, you've lost your information the same way. So there's big backup units, big generators to generate electricity that's sufficient to power that whole facility. Again, the cost to build in that redundancy is tremendous, and it's only by spreading it out among the different users that those costs actually become lower instead of higher if you had to replace it for yourself. The savings, I think we've just started to tap, and I think that it's going to grow and it's going to be a massive thing. It really will be. Now, slide 10 of this presentation does not do anything any justice. And what I'm really trying to point out here is I'm trying to pass on a couple of tips that everyone can use. I am a firm believer that in small business, unless you grasp, learn, and use technology, you're dead, because things are moving just too fast to keep up, and you'll get left behind. The slide 10 is a part of an infographic, and an infographic is something that's being used today. I'll put that on the web where you can see the whole thing. And each of the slides beforehand was where I sliced it up in order to fit the size of a PowerPoint slide. Okay, then I was able to do it. But as an infographic, you can see it's a combination of pictures or graphs and a layout to where you can put a lot of information in one place and take up relatively little space. Again, it's a concept of the web age, and that's basically what we're talking about. Then I used the Adobe Elements thing in order to slice up the graphics and do it. And again, if you look at, it's almost the same thing as what Photoshop was. And Photoshop was a very expensive application. The Adobe Elements, along with the movie maker concept of it, both programs will run in the neighborhood of about $120. And that's very economical, and it has just about exactly the same capabilities as what the original Photoshop does. And the Movie Maker is actually better than what the Microsoft Movie Maker is. Okay, the other thing that I used in order to put all of this stuff together was a package called AVS4U. It is a suite of about 9 different audio-video applications. It's headquartered out of the United Kingdom, so it's only available on the internet. It's not available in stores. The service is great, and the price is right. For the suite of the 9 applications, it's about $60 for a lifetime license to use the product. Lifetime, the only limitation is that it can only go on one machine.
And so their business model is good because as you change machines, well, you got to buy another application. But they're very simple to use, and their service is great, even though their service is only by email. But within 24, 48 hours, you've got an answer, and they usually have it right for you. So I would encourage all of you to take a look at it and see if you can use it, and I'm sure that it will work as well for you as it is for me. So this is one great big experiment. Always keep in mind to keep growing and trying new things. With that, I hope you have a good time, and we'll see you next week.